Okay, this lesson is on adding, subtracting, and multiplying polynomials. And so this is largely a review of some algebra stuff that we've been doing for a couple years now. And so it's good to kind of, when we start to do some higher level algebra, to come back to some of the basic skills of algebra so we understand what's happening. So the learning goal is to simplify polynomial expressions in order to discover information about functions more easily. And the easily part, like, it's not going to come so much in this unit. It'll come throughout the course, but like simplifying polynomial expressions, it allows you to plug in points more easily. It allows you to like tell characteristics about the polynomial more easily. And some of that's going to be seen in this unit, but some of that will be seen in the future too. So adding, subtracting, and multiplying polynomials. And each of the times we're talking about making equivalent algebraic expressions, and so that'll be a focus of this lesson. And then a combination of adding, subtracting, and multiplying. So a question just to start is like, which pair of functions are equivalent? And so if you look at the first pair there, like you can tell that they're algebraically not the same. So you can tell that they're not equivalent. But it's important to say that like the sign really does matter. Like -3 is not the same as +3. But if you want to prove that they're not the same, apart from graphing them, you could just sub in a point. So if we sub in 0, we get 5 for F, and we get -5 for G. And so they're actually not equivalent. The second one, if we want to prove that they're equivalent or not equivalent, we could find out if they're algebraically the same. And so we're going to practice this in this lesson. So the first one I'll simplify to 7x minus 6, and the other one's 7x plus 2. And so we can tell that they're algebraically not equivalent. And so one's 7x minus 6, and the other one's 7x plus 2. The next one, you kind of get the feeling that you're not equivalent, but this one's good because like if you sub in x equals 1, you do get the same thing, and that doesn't mean that they're the same. If you sub in x is 0, you get 8 or 9, which is different. And then D, you can either distribute f of x, or sorry, factor f of x, or distribute g of x. And there's just a typo here that should say g of x, but if you expand this out, you actually get that they're the same thing, 18x minus 24, so that's actually equivalent. Couple definitions. So polynomial is an expression with variables and coefficients. You're only using addition, subtraction, multiplication, and there's no negative exponents. Like terms are just things that have the same variable, and so we can actually combine like terms or simplify polynomials by combining like terms. Coefficients don't need to match, just tells you how many of that object you have. To prove equivalence, you need to be able to verify that they're algebraically the same. When we get into factoring, like this is going to be really important because we can actually expand them back out and make sure that you get the same thing. When we write equals, we're not just kind of saying like, oh, you got to write good form. It's not just like a little thing. The equals is very purposeful. If you write equals, then you know you're simplifying something that's to something that it's equal to. If you don't write the equal sign, you maybe get caught up in writing something that's not equal. But you also, by writing the equal sign, you're really kind of thinking about the fact that they're equal. And to prove things that are not equivalent, you just have to find one point. That doesn't mean that, like, if they're equal, you get the same answer. That doesn't mean that the relations are equal. It just means that they share that point. They might be equal, but they certainly might not be. So sometimes we just have to try different numbers and make sure that they're equal for a lot of different numbers. And that still doesn't prove that they're the same. The only way to prove that they're the same is to do the algebra. So here's some practice questions. So the first one, we can actually just drop the brackets because they're not doing anything. Brackets are used to help group, and when an operation has to be applied to everything in the bracket. You can see in B that the brackets do matter because you're doing a minus, and in C the brackets matter because you have these 2x and the 3x squared. But the first one, we can actually just drop the brackets. So that will be the first step when we simplify. I like to actually group like terms by stacking them. So the x squared minus x plus 3 I just put under. And it's kind of easier to like add them if they're stacked. We're actually used to like adding things that are stacked. But then when we learn algebra, we kind of write it in one long row. It's a nice technique to like stack them. So you get 4x squared minus 8x plus 8. So this is 3x squared, and then another x squared gives you 4x squared. The second one, when we drop the brackets, you actually have to subtract everything, not just the first guy. So you subtract -6 and subtract 5. And so we distribute the negative to all three. And so the signs all change. And then when we stack them, we can see the canceling out and the -4 is left. The next one, you distribute the 2x, so you get 2x squared. So that's 2x times x. So what this is 2x times x, which is 2x squared. And 2x times -3 is -6x. The second one is 3x squared times x, which is 3x cubed. So 3x x times x. And then 3x squared times -3 is -9x squared. And we can just put that guy with there so we know like that they're like terms. And then when we simplify, we say 3x cubed at the beginning because it's the biggest exponent. And then subtract here, we get -7, and then you've got the -6. Question is like, are these functions equivalent? And we're gonna actually expand or actually look at these more in depth in a second. But when you look at these, like a lot of people actually say, yeah, they are equivalent because like 2x plus 3 is 4x squared plus 9. But if you realize like BEDMAS has to happen, and so like you have to do the bracket before you do the exponent, realize if you subbed in the number like 1 here, you would get 2 times 1, which is 2, plus 3. Squared is 5, and square 5, you get 25. But for the other one, you're actually getting 13. So you ask yourself, like, well, then they can't be equivalent. And so you're actually missing something if you just expand this in. And you think about it, like, if you had just 2 plus 3 squared, you can't say that that's like 4 plus 9. It's 25. 4 plus 9 is not the same. So like a big idea is going to be like the same rules that apply for numbers apply for algebra. And if you can't do it for numbers, then you can't do it for algebra. So some rules that we have is commutative property, and this isn't an algebra question, but like it's just the idea that like if you want to add these up, like what's the quickest way to add these up? And so I might want to put the negatives and the positives together and say that it's 20 minus 10. We do the same kind of thing when we group like terms. We put the things together that work so that we can simplify. The commutative property means that like you can move things around and the signs go with the number, but the order doesn't really matter. No matter how you do it, it'll work. The associative property means when like you're multiplying, the order doesn't matter. And so if you have something like this that you need to simplify, some people might say, oh, I can't, like these are not like terms. But if you look, you've got 2 x's and a y, and here you've got 2 x's and a y. So these are like terms. And really, it's better just to put them in alphabetical order. So you got 2 x's and a y and 2 x's and a y, and so this is actually the same thing. 2 times 3 times 4 would be the same as 2 times 4 times 3. It would give you the same thing. And so you can simplify that to 3x squared y. Some people have trouble with this, like they just like have to review how to do this, and so remember that x squared y is almost like a volume. It's a three-dimensional shape, like a x squared times a y, and then you have one of them here, and then so here you have two of them, 2x squared y, so then in total you have 3 of them. The distributive property is where you can take something, and we've already done this, like multiply it. And so 2xy times 3xy, and then 2xy times -5x squared y squared. And then you'd say like, okay, well if order doesn't matter when we multiply, we can say 2xy times 3xy would mean like, all right, let's multiply the 2 and the 3 together because we can. And let's put the x's together and the y's together. And so you've got 6x squared y squared. And then 2xy times -5 times x times y times y would mean 2 times -5, which is -10, and then 3 x's and 3 y's. Multiplying polynomials is just an extension of distributive property, which would look like this. And so if you've got, like, the first one is really just a question of expanding. So 2a times a is 2a squared, and 2a times 5 is 10a. And then this question here, just make sure that you're really good at it, because when we factor, you're going to want to be able to do this really quickly and very well, like very accurately. So you have two objects, two binomials, so 2 here and 2 here, 2 terms in both. So if you multiply 2 terms by 2 terms, you should get 4 terms. And so each arrow will represent the term. 2x times x, 2x squared. 2x times -4 is -8x. 3 times x is 3x. And 3 times -4 is -12. Combining like terms in the middle, you get the -5x. And that's simplified. The next one, you've actually got a binomial and a trinomial, and so if you've got 2 times 3, so two objects times 3 objects, you should get 6. And you should see that you can see the arrows. 3x times x squared, 3x cubed. 3x times -5x is -15x squared, and 3x times 1 is 3x. And we put the arrows under for the 2, so 2 times x squared is 2x squared, and we can stack them so that we don't get lost. 2 times -5x is -10x, and 2 times 1 is 2. And then with them stacked, they're actually pretty easy to add. 3x cubed minus 13x squared minus 7x plus 2. And the last one's kind of like the question where we asked if they're equivalent. So what you actually have to do when you have an exponent, and this will be the focus on the next lesson, is actually write it out 3 times. You can't say that this is a cubed plus 8b cubed. It just won't work. That a cubed and 8b cubed are going to actually be terms in the end, but they're not going to be the final answer. So what you actually do is you write it out 3 times, and we do the first 2 brackets first, leaving brackets around the answer to multiply by the third one. And so you'll see, like, as we go, the first 2 brackets multiply to this, and then we have the third. They simplify to like these 3 things times 2, and then you've got something like this, which we'll like look at the next slide. And so you can like actually combine like terms, or sorry, do the distributive law, and then combine like terms, and that's your final answer. And I just ask you that you reflect on like the pattern here, and so if you can kind of notice some kind of pattern happening with the variables for now, and then we'll deal with the coefficients in the next lesson. But certainly there is a pattern that's happening with the A's and the B's here.